right, today we're going to continue with pre-algebra, and I want to talk about pre-algebra skills. First, to review your own pre-algebra skills, and then to finish up with teaching some pre-algebra skills. Then Tuesday, of course, is our last class period. We're going to do story problems and finish a few things for you. All right, so with pre-algebra, what about your own skills? What about your own algebra skills so that you would be able to handle pre-algebra? I think what we need to know in pre-algebra, the goal would be negative numbers. Okay. And then the goal would be order of operations. What we're doing now in 7th grade math is we went through all of the negative numbers, how to add, subtract, multiply, and divide them. And now we are applying them to the order of operations. And the students are struggling because not only do they have to pay attention to the order, now there's negative numbers in there, and they're making quite a few mistakes. So order of operations, negative numbers, and then algebra terminology. Talked quite a bit about the transition from arithmetic to algebra, and then we've got to do expressions, algebraic expressions, once we get the terminology down, and then equations and simple story problems. That to me would be the scope of pre-algebra, even in 7th grade. 8th grade we're going to do a little more down there. We're going to do harder expressions, harder equations, and harder story problems. What we're doing is we're setting the stage. And I think they're going to be, especially the 7th graders, are going to be especially ready for pre-algebra in 8th grade if they've got the negative numbers down. Then we can concentrate on algebra without dealing with the integer, the new integers, the negative numbers. So what about your own algebra skills? Let's do a quick review of algebra, a quick review of terminology. I like to call these the building blocks of algebraic expressions and equations and so forth. We'll begin at the very bottom with variables, and constants. At the bottom of our algebraic pyramid, that's not too bad looking, right? What is a variable? Well, terminology, we use that all the time, but a variable is a lowercase letter used to represent an unknown quantity. So this is abstract. Now we are going to use a lowercase letter to represent an unknown quantity. Many times we'll start using the letter n because it's representing a number, and then the classic variable for algebra is x. And then as you need more variables, you're going to use x, y, z. I like to do z like this so that it doesn't look like a y, and so it doesn't look like a 2. If you use the cursive z, it can kind of degrade into a y and so forth. And notice I'm always working to use cursive. Variables should be written in cursive so they don't degrade into numbers, and so you can tell the difference between L and 1, so you can tell the difference between X and Y. Because what happens if you use print, what happens to X is eventually it becomes a Y. So, and it must be lowercase. In mathematics, we capitalize and lowercase for specific reasons, okay? Capital letters in algebra represent integers. Lowercase can be any unknown quantity. Also, we reserve capital letters for vertices in geometry. So a variable is a lowercase letter used to represent an unknown quantity. Like I said, N, X, keep on the cursive, kind of except for Z, A, B, don't use B. What happens to B? It becomes a 6. Be careful with A. Curl up the tail of the A, or what happens to A? Becomes 9. So cursive letters, C. So a variable is a lowercase letter used to represent an unknown quantity. It needs to be in cursive, and it needs to be lowercase. All right, then a constant. A constant is a quantity that never changes. It's constant. It's a quantity that never changes. It can be an integer, it can be a fraction, it can be a decimal, it can be any number, but it can also be a particular value in science. Pi is a constant. Right? And you've heard of different constants that are used in computations in physical science in particular. All right, and then while we're on the topic of variables, I like to use X, Y, Z, A, B, C, N. I avoid using, sometimes textbooks just use all the letters of the alphabet. I do not use T. Why? Time. I do not use S. Why? Speed. I certainly wouldn't use M. Slope. We've got enough letters here. We don't need to use letters that are, or don't use G. Why not? Gravity, okay. Other things too. So use the same variables all the time, especially in pre-algebra. We don't want to be throwing all these odd letters at them all the time. Let's stick with N, let's stick with X, let's stick with Y, A, B, C if we need to. All right, so variables, then constants, when they're multiplied together, what do they become? Coefficients. Coefficients will then make up a term. You are correct in your thinking there. Okay, so variables times constants become coefficients. A coefficient, what are coefficients? A coefficient is a factor of a term. So we take a variable times a constant, we write them as coefficients. This is the numerical coefficient, this is the literal coefficient, isn't it? Though nobody uses literal coefficient, but they are coefficients of each other. 3 and X are said to be coefficients of each other because they are the factors of a term. So coefficients are the factors of a term composed of variables and constants that are multiplied together. That's kind of a tautologue. If it's a factor, it implies multiplication, doesn't it? And we do have the numerical coefficient and the literal coefficient. Also involved with coefficients, we can have more than one. If we have 3 times X times X times Y times Y times Y. Now when we have multiple repetitions in our coefficients, we're going to write it as, when we write this as a term, we will use exponents. So this now altogether is called a term. Individually, they're coefficients, in particular the numerical coefficient and then the literal coefficients. But now that we're starting to get a little more complicated here, X has another name because of the exponent, and what is it? Because X has an exponent, what is it also called? the base. So x is the base of the exponent 2, y is the base of the exponent 3. So we have exponents and bases that can also be coefficients, can be part of our algebraic term. So what is an exponent? An exponent is a superscript. Okay, it's a superscript. It's a superscript quantity. It can be a number, it can be a constant, or a variable. We do have superscripts, we do have exponents that are variables. All right, so it is a superscript number or variable that tells how many times the base is taken as a factor of itself. Okay, so how many times that base is going to be used as a factor with itself. Okay, so you know that x squared tells you to use x as a base 2 times, use y as the base 3 times. So how many times the base is used as a factor with itself? Base. A base then is any variable, constant, or even expression acted upon by an exponent. Simply speaking, a lot of times we're used to seeing individual bases, but we can have a constant as a base, we can have a single variable as a base, we can have a term as a base. And of course, remember this from your algebra days. If I want the sign to be included in the base, what do I use? Parentheses. This is -3 quantity cubed. This is x squared y quantity cubed. A lot of little details. It can even be an entire expression, can even be acted upon by an exponent or raised to a higher power. So we do have a lot of terminology. 7th graders have worked with and done exponents and bases, but not to the extent that they're going to. All right, so we have variables times constants give us coefficients, which make up a term. Coefficients are the factors of a term. Then terms. Uh-oh, I'm getting too small here. Terms make up expressions, right? So terms then are the add-ins of an expression. Terms are the add-ins of an expression composed of a group of coefficients. So we have variables and constants. We multiply them together, they become individually coefficients, and they make up a term. Coefficients then are the factors of a term. And they're composed of variables and constants. Then we go up to the term level. What are terms? Terms are the add-ins of an expression. And they are composed of coefficients. So this then, we've got our numerical coefficient, our literal coefficients, also our variables and our bases. Together, this entire expression is called a term. And terms then are the add-ins of an expression. Here's an expression right here. An expression is made up of terms. So an expression is a group of terms added together. So if I have, let's just take a classic example of something that will be seen a lot in Algebra 1 and beginning to be seen a lot in 8th grade pre-algebra. This is an expression. An expression. What is an expression? It's a group of terms that have been added together, because remember, terms are the add-ins of an expression. This particular expression, there's a lot of details to learn with this and to review with this. This expression has 3 add-ins, doesn't it? That makes it a trinomial. The expression that I erased, my x plus 3y quantity squared, or quantity cubed I had, that is a binomial because it has 2 add-ins. My original term down here is a monomial because it has 1 add-in or 1 term. So there's my expression. Actually it is a perfect square trinomial. Do you recognize the pattern? X squared x with the constant. With this, they are considered to be add-ins. We're not subtrahends, right? So here, this particular term, a couple of things to remember about it. The first thing to remember is it has an understood 1 as a numerical coefficient, never written. Second thing is that it's also called the leading term because it is the term of highest degree. Second degree, referring to the exponent. Understood first degree, 0 degree. We'll get to that in a second. So this is the leading term because it is the highest power. It is written first. It does have the understood 1, which is not written. The middle term. The middle term has a numerical coefficient of -2. We don't consider subtraction, do we? And an understood exponent of 1. All of those little details are things we start using and teaching in pre-algebra so we don't trip over it in Algebra 1. I want to be able to factor this in Algebra 1. I don't want to be teaching what it is. All right, and actually in 7th grade they enjoy the new terminology. They enjoy the algebra because they don't have to do all this computation like they've been doing all year in arithmetic. So we have expressions, okay? Expressions are a group of terms that are added together. Also with this expression, the first 2 terms can also be referred to as the variable terms, and the last one is the constant term. There's all kinds of terminology that needs to be used and taught. So pre-algebra, for intermediate math, here's where we're going to be teaching new concepts, switching gears, transitioning from arithmetic to algebra. So we'll begin back at the beginning. We have to really work on terminology, okay? Because they need to understand what the teacher is saying when we refer to the leading term, or we refer to, obviously, the base, or we refer to the trinomial and the binomial when I talk about squaring a binomial, and so on. There seems to always be a breakdown in language. I often see this breakdown in language in Algebra 1 when we're learning things like this. Does anybody remember what that expression is called? The difference of 2 squares. Why is it called the difference of 2 squares? Because that's what it is. Look at it. Difference. What's this? A square and a square. So it's called the difference of 2 squares. That's very hard for students to get a hold of, and they try to remember it. What have we said all year about memorization? It's temporary. So we want to reach the understanding. So we're working to set a good foundation. This is almost like primary math all over again, because we are now switching gears to high school mathematics. So 6th grade, 7th grade, 6th grade starts on the negative numbers in most curriculum. Okay, in most of the curriculums. And so we have to start with the terminology, and we build a solid foundation for our 7th graders and 8th graders. And then in algebra and in high school, they can learn how to really do algebra instead of constantly having to trip over sign errors, trip over order errors, and so forth. Okay, in the academy this year, and I have for the last, I don't know how many years, we are already done with the textbook. And so what am I doing? I'm taking them a step further, and then I'm reviewing, and we're having a massive semester exam. Why am I able to do that? Because I don't have to go back and teach negative numbers. I don't have to teach terminology. I do review it and solidify it and make sure they know how I use the algebra terminology, but I'm able to jump right into equations and story problems. And then when I do polynomials, all I have to do is review, because they already know how to work expressions. The first test that I give them in the fall, I call it, the test is called Beginning Algebra. And I can give it right away, and they do very well, because all it is pre-algebra. And then I can start really doing algebra so that they're adequately prepared for the next level in high school. So that's what we're doing here with pre-algebra and intermediate level. We're going back, and we have to set a foundation just as much as first grade sets the foundation for arithmetic. Intermediate sets the foundation for high school math, which means negative numbers are no different than positive numbers, are they? We don't pay any attention. We don't have to. The goal here would be for the 8th graders, by the time they're done with 8th grade, that they don't really care about negative numbers. Think about your own math skills. You don't pay attention. You don't care if it's a negative number, do you? Not if you did well in algebra and you've had algebra 1 and algebra 2. Who cares if it's a negative number? It's no different than a positive. So that's the goal by the end of 8th grade for sure, is that what's a negative number? I start from the very beginning in algebra 1 just doing negatives and positives all mixed up, because we've had hopefully adequate practice in intermediate in 6th grade, 7th grade, and 8th grade. Same thing then with the terminology. Okay, so we have then expressions. We have expressions. What's an expression? It's a group of terms added together. And what branch of algebra are we actually doing? We're doing polynomials. So the expressions, the typical regular algebraic expressions, are called polynomials. And in the Bob Jones algebra curriculum that we are using in 9th grade, it's chapter 8. So much of what I teach, I completely skip chapters 1, 2, and 3, and I start in chapter 4. Okay, and that's due to the fact that we are done what we need to do in the intermediate with our pre-algebra. All right, so in expressions that we are dealing with are actually belong to the group of polynomials. So in algebra 1, I want to teach polynomials. I want to teach radical expressions. I want to teach quadratic equations. I want to teach rational expressions. I don't want to be doing all this basic stuff, okay? So then the expressions that we're dealing with are technically called polynomials. And polynomials can be subdivided and further named into monomials, binomials, and trinomials based on the particular number of terms. Now they're all polynomials, but when we're working with them at most levels, we do deal a lot with 1 term, 2 terms, and 3 terms, so they have specific names. But a polynomial basically is any algebraic expression composed of terms. Once we start introducing denominators, they become rational expressions. Once we start introducing square roots and other radicals, they become radical expressions. But we're going to be setting the foundation so that our soon-to-be ninth graders can start right away into learning about polynomials instead of having to learn the negative numbers, having to learn order of operations, having to learn even simple equations. Okay? So then we have expressions on the top, the final tip of our, I don't know what we call that, Tower of Babel. We have equations. Ultimately, we work with expressions so that we can solve equations. An equation is two equal expressions. An equation is two equal expressions. So, terminology. I want to make sure that my students know the terminology. I do use vocabulary quizzes, and then I use it in class, and I try to make them use the correct term instead of saying the x or the x squared. Say, no, that's the leading term. So, terminology is a big part when you're transitioning from arithmetic to algebra. You are laying the foundation for their high school math, and so we have to begin with terminology just as much as the first graders do. Okay, so now let's deal with algebraic expressions. So do you know the terminology behind algebraic expressions? Now, when we are dealing with algebraic expressions, remember, they are polynomials, technically. What's a polynomial? It's a many-termed expression. Same as polygon, many terms. All right, and so we're going to deal with our polynomials, and basically the first thing that we learn to do with an expression is we learn to evaluate it. So with our expressions, we are going to learn to do two things. We're going to learn to evaluate them and simplify them. In 7th grade, I'm centering in on this one primarily, and only a tiny bit on this one. And then we're going to be doing some simple equations, which they've been doing since, they've been finding missing numbers for a long time now. But they have been solving, I guess we'll use the expression, real equations since about 5th and 6th grade for sure. All right, so how do you evaluate expressions? This is where you are given each variable, the value of each variable, and you must find the value of the entire expression. Evaluate. And we're going to do this by substitution, and we're going to follow the order of operations, and we're going to use this. We're going to use our pre-algebra time to not only teach them the terminology, not only solidify their negative numbers and get those negative numbers down pat, we're also going to use it to establish good habits. Okay? So let's put that right here. The biggest problem, I think one of the biggest problems, let's put it that way, in 7th grade math that I have trouble with them is showing their work. They do stuff all over the page. Disorganized work. What happens in algebra when you're sloppy and disorganized and you write stuff big here, little there, skip a line, don't skip a line, leave this up here, forget to bring it down? What happens to something that's a relatively easy operation becomes a mess? I leave out this variable. I forgot the +1. So we need to train them to use algebraic format. What's for algebraic format? We talked about it in the transition. It's the problem is now horizontal and the steps go down, versus arithmetic where the problem is vertical and we wrote the steps sideways and did it in a vertical format. Now we have to train them to use step-by-step horizontal format. And to do that, we're going to use evaluation to instill this habit. If you get your 7th and 8th graders to write things neatly, keep them line by line, keep it neat and organized, algebra is not hard. Algebra, though, can be a little meticulous. So if you're careless, you're going to be losing variables, you're going to be making sign errors, and so forth. So, and this is what in the textbook you'll be doing in Chapter 11. Chapter 11, Section 1 is on variable expressions, what I call algebraic expressions. And the first thing that we do is we evaluate them, and then, which is Section A, and then we're going to be simplifying them. So let's do some evaluating, and let me show you what I mean by horizontal format and working it down one step at a time. So when I evaluate, the first thing I do is I copy my expression. Let's say I have, we'll start simple, 2x minus 3y plus 7. And I will have to be given each variable. All right, so I require them to copy the expression, not do this haphazard substitution. Haphazard. Haphazard causes algebraic disasters. So I make them copy the expression. Then the next step is I have them directly below, not off center, not over here, not on the side. I want to see this. And we teach them every detail of how it needs to be done. I use parentheses for multiplication because the little dot, well, the x is no more in algebra, and the dot gets lost. Dots also evolve. I've seen a lot of evolution in 7th grade math, okay, and in Algebra 1. And what happens is dots get a little fatter. Well, actually, especially the students that write very small, their dot becomes what? A subtraction. It does. Or they don't usually lose it entirely. It usually evolves into a different operation. Also, this is something else to train your students to do. When it's a negative number, keep that negative sign closely associated with the number 3. That is not 3, it's negative 3. Now, the parenthesis does both here. So, the first thing I do is I copy the expression, then I show the substitution decently in order, directly straight below it, keep it neat, keep it right below, right below. Then, evaluate also requires the use of the order of operations. But what I like to do is I like to teach them in Algebra 1 to evaluate, and here's how we do it. We're going to do it term by term. I'm going to do it algebraically now, not just order of operations. Term by term, because according to the order of operations, addition and subtraction are last. So I simplify the entire term, simplify the middle term, simplify each one. So what happens here, you've had algebra, haven't you? So you're going to automatically do this, I hope. Right? 7th grader? Not so much. The in-between step would look like this, and this causes problems. But if I've taught the negative numbers properly, they're going to think of this as negative 3 times negative 3. We don't want to do this. Do you see what I'm talking about? That's a problem, and that's why I teach the negative numbers the way I do. There's no such thing as -3. This is -3 times -3. Then I can go directly here and avoid that extra sign. This can be a sign error. Here it is, potential sign error. Deal with it. And know it's coming so you can prepare for it and even teach them in a certain way to avoid things. This is a common sign error. So teach them term by term so that they are in the habit of doing the addition last, and they're in the habit of not thinking of that as -3. It's -3 times -3. How do you do that? You do that by assuming addition. You train it in the negative number section. And then we're able to do a lot of these things intuitively, especially once we get into 9th grade, and hopefully for sure by 10th grade or 11th or whenever Algebra 2 is coming along. All right, so then I have 20. So I teach them to write the expression, substitute into the expression, simplify each term of the expression, then combine the like terms. Well, by this time there are no like terms, they're all constants. Okay, and teach them to do step by step. I also do not allow them to use an equal sign. They want to do this. No. What am I doing? I know what's coming, and I don't want them to be getting into trouble with making expressions into equations that aren't equations. Okay? This is not an equation. It's not allowed an equal sign. Okay? The answer goes below. Not an equation, no equal sign. I said, well, it's okay, that's equivalent, that's true. Well, yes, it is true, but I'm not doing an equation, and I want to keep the equations separate from the expressions when I'm teaching pre-algebra. Okay, does it make sense? That's another potential problem for down the road, so I'm trying to give them good habits. It kind of helps that I'm the 9th grade teacher as well. Okay, so I am heading off habits that I don't want to deal with 2 years from now. Okay, so can you evaluate algebraic expressions? Let me show you one more. Let me show you the value of evaluating term by term instead of just using the order of operations. Okay, we still use the order of operations. Let's add another variable, let's add z, and let's make z be -4. Don't protect your students from negative numbers. Don't protect your students from problems that are harder. Don't protect your students from problems that may have sign errors in them. Don't protect your students from difficulty, just like you shouldn't protect your children from difficulty, right? So don't protect your students from negative numbers. Don't protect your students from story problems. What are you doing? You're hindering them down the road. So let's throw the negatives in there. Now, when I first teach evaluating, I might avoid negative numbers, but I can't ignore them, especially not with my Bob Jones textbook, because they don't. Okay, and then I'm going to have sign errors. Let's address the problem as it comes up instead of after the homework, kind of before the homework. All right, let's do this expression. I've got a couple things that I use constantly because it always trips students up. So let's do the hard problem in class. Let's address the tripping point and not ignore it. All right, when I substitute in, I get this. All right, here again is the value of using a negative sign, using a parenthesis to keep that negative with that 3. Am I squaring 3? No, I'm squaring -3. Same case here. Where's the sign error going to be? Who knows? So I'm not teaching algebra. No, you're not. But if you're teaching below algebra, you want, where's the sign here? What do students want to do? They want to do this. Because Mrs. Wright has trained them to change the sign and add when they see the negative sign. What's that? That's an order error. We have to do the square first. Changing the sign corresponds to subtraction. This is an order error, and this can be eliminated by going term by term. So I teach them to simplify term by term. I'm trying to avoid order errors. I'm trying to avoid sign errors. And so what do? I simplify this guy. I copy my addition and subtraction down. They're dead last. And I simplify this term and I simplify that term, term by term. And when they're at the blackboard, I'm not letting them skate by with sloppy, messy, and not showing procedure. So then this is a whole lot different. It's not going to be 29. What is it going to be? Negative 11. We're going to collect our like signs. This is not minus 9. It's 4 and negative 9 and negative 16. So when I collect my negatives, I get what? Negative 25 minus 4 is negative 21. Okay? I think I said 11. I was in the wrong tens. All right, do you see what I mean about how to teach mathematics? Okay, so, and actually, this has taken me years and years of trial and error. Okay, and so the purpose of this class is to try to have you be a little more aware of things so you have less trial and error. Okay, you're supposed to be teaching students and pupils and children, not kids, which are baby goats, and not guinea pigs or mice that are being experimented upon. Okay? So you yourself will need to be able to evaluate algebraic expressions. And watch out, what am I going to do on that quiz? I'm going to try to get you to make an order error, or I'm going to try to get you to make a sign error. So be on your toes yourself. All right? You're going to be doing page 463. Evaluate the valuable expressions when A is negative 3, B is 6, and C is negative 2. The last thing that we're going to do with our algebraic expressions is simplify them. And the same idea is going to be true with simplifying. I need to establish good habits. I need to reinforce algebraic format. Okay? And so I'm going to teach them to simplify, and I also have to go back to terminology. Even with the verbs that they're going to encounter in their directions. They're going to see evaluate. And what does that mean? It's really obvious what it means to us, but it's not obvious to what are they supposed to do? Okay, look, they gave you what A is, they gave you what B is, they gave you what C is. What do you think you're going to do with it? Evaluate, put in the values. But even more than that, we want to teach the meaning of this word in its algebraic context. Because I'm going to be using that word a lot. I'm going to tell them to simplify before they solve. Well, that's nice. Well, it's not nice if they don't know what I mean when I use the word simplify. In algebra, the word simplify with respect to polynomials, what does simplify mean? What is the direction telling them to do? If they read the directions, right? Sometimes they don't. But what does simplify always mean? So what can I tell them with respect to polynomials? Guess what? Simplify has the same meaning. It means to remove parentheses and combine like terms. In that order. Okay, and so I'm teaching pre-algebra. I am not teaching Algebra 1. Algebra 1, I still define a lot of my terms, but I don't have to teach them things like terms. All right? I use this constantly, combine like terms. What does that mean? Terminology. The language of the learner has to be the same language as the teacher. So I have to, when I'm now teaching how to simplify, I have to make sure every single student knows what I mean when I use this phrase over and over and over again. I'll tell them you can only combine like terms. By the way, where does this come from? Come on, guys. It comes from the law of addition. What is the law with respect to addition? You can only add like quantities. So that means I can only add feet to feet. I can only add thirds to thirds. I can only add the ones place to the ones place, or the tenths place to the tens place. It means I can only add x to x, x to other x's, right? Y's to other y's, ab's to other ab's, x squareds to other x squareds, etc. So I have to teach like terms. The law of addition tells me only likes may be added. Now what's behind this word? Combine replaces what other verb? Add. Why does combine replace add? I erased it. Because unfortunately, not all of us are going to assume addition. We're not all going to assume addition. So I'm going to reinforce that idea. I'm not going to add, I am going to add, but I'm not even going to say it. I'm going to say x minus 3x, aren't I? But what do I mean? I mean x and negative 3x. So I'm going to make sure I reinforce the understood one, and I'm not going to protect them from negatives. So what is? Now I have to combine these. So that has the idea that there is no distinction between addition and subtraction. We don't use subtraction. We have negative 3, not minus 3. So what is that? Negative 2x. I'm not going to start with this. I'm starting it with you because you have had high school algebra 1 and 2 probably. So do you see where the combined like terms comes from? I'm going to use it. So simplify, I have to make sure they know what I mean when I say simplify both sides of your equation before you start solving it. Every time they see the word simplify with respect to polynomials, they're going to always remove parentheses, combine like terms. Okay? So when we start in chapter 11, we start working on simplifying an algebraic expression. We'll start, you can see what they do. The first thing they do in their objective B is they just have addition and subtraction. Just teach the part about combining like terms. And so we have to stress what like terms mean. What are like terms? The idea here is only the numerical coefficient can be different. The variable coefficient has to be identical. Coefficients. We could almost call them identical terms, but we don't, because the numerical coefficient, only the numerical coefficient can be different. All right, only the numerical coefficient can be different. So 3x and 2x squared are not like terms. The variable part of the term has to be identical. Okay, so like terms, only the numerical coefficient can be different. And this is important because later on we'll be adding radicals. Are these like terms? No. Only the new, but now if I do this, switch things around a bit, this is the numerical coefficient, isn't it? That's a radical. So we're still going to be working on the idea that like terms mean only the numerical coefficient can be different, and only the numerical coefficient is actually going to be added, right? We're usually okay with this. Every once in a while, I will have a student do this in 9th grade. I think they're having I don't know, maybe they're having a seizure or something, or a slight stroke. All right, that's because I have to continually stress that when I am combining like terms, when I am simplifying my expression, the first thing I do is add like terms, and only the numerical coefficient can be different, or they cannot be added, and then only the numerical coefficient will actually be added. All right, so a lot of times this will happen after we start getting into multiplication. They'll start confusing the two. But if I have 3x plus 4x plus 7x, it is not going to be 14x squared. Once I teach the exponent laws and you teach that multiplication, you add exponents, then we start having a little confusion. Though we don't do the exponent laws in pre-algebra 7th grade. You might start with them. We do the exponent laws in 8th grade math. All right, so we have to teach them to combine like terms first, and we have to teach them that for it to be a like term, only the numerical coefficients can be different. And then the other thing we have to teach them, also dealing with the numerical coefficient, is that the negative sign is part of the numerical coefficient. Keep the sign with the number. It's part of that numerical coefficient. All right, so you might see they might see stuff like this. What is that? I'm combining, and I'm combining like terms. I can only combine the numerical coefficient, and the negative sign is just as much the numerical coefficient as the 2 is. Okay, so combining of like terms. Only the numerical coefficient can be different. Only the numerical coefficient is added. Then when we get to parentheses, this is the first step, but we teach it after we get the second part down. Then we'll go back and pick up the first part, the parentheses, and then we'll put the two together. Clearing a parentheses is so important that it has a name. And the 7th grade math curriculum teaches the distributive property with all the other properties. Commutative, associative, identity, inverse, and distributive is critical. So you learn it by name to put a nice stress on it. And so the next thing that we learn is how to distribute a factor through a sum. That's what we do. We distribute a factor through a sum when there's a parenthesis. So if I have, at pre-algebra level, we are not going to have a variable here. That becomes doing major polynomial multiplication. We start with only a number here, and we're going to distribute the factor 3 through the parenthesis. The distributive property tells me that this means 3 times A plus 6B. 3 times A, 3 times 2B is 6B. Okay? And we're going to avoid the exponent issue here at the beginning, especially 7th. That is the distributive property. What's the opposite of distributive property? Which 7th and 8th graders do a little bit, 7th graders do not. Factoring. Okay? Remember, equal signs are both ways. Right, so you'll be using the distributive property. Guess what else we have to do? We have to address sign errors. If I had a dime for every time this sign error occurs in 7th grade, and especially in 9th grade because they do it quite a bit, I think I'd be driving a 2018 vehicle. Okay? So, potential sign error alert, okay? Trying to do that with the 7th graders. We have sign error alerts, okay, because they're a problem. Do you want your students struggling with the harder things second semester because they keep making sign errors? Right? I have a sign error problem going on right now with my rational equations. Here's the sign error alert. See if you recognize it. Sign error alert. What is the most common sign error of the distributive property? The answer is negative 4x plus 14. I am honestly not exaggerating about this sign error alert. Happens over and over and over and over again. And a lot of times it's the same person. I keep thinking to myself, if I made that sign error as many times as you did, I think I would start recognizing it. Sign error alert. Don't do it. All right, then the last thing, of course, is to put the two concepts together. Because simplify means two things. With respect to polynomials, which is a big part of what we're going to do, it's the only thing we're going to do in pre-algebra, and it's a big part of what we're going to do in Algebra 1. When it says to simplify an expression, it always means to remove parentheses, combine like terms. Okay? So that means after we figure out and get the like terms practiced and kind of down pat, then we learn the distributive property. That's how we remove parentheses. We will put 2 and 2 together. Step 1, remove the parenthesis. In step 1, don't protect your students from sign errors. Keep doing them, keep doing them, keep doing them. I don't mean the sign error, but keep showing them, keep reinforcing them. The fact that they have to think of this as -3. They can't think of it as -3. Got it? And that goes back to teaching the negative numbers properly. Teach the negative numbers from an algebraic perspective, not an arithmetic perspective. This is called pre-algebra. So I copy the 5x down. Don't let them do the thing and then leave the 5x hanging up here, leave the 8. Or they're going to lose the 8. We don't allow them to leave the 5x hanging up here and the 8 hanging up here. So I distribute, and notice that I use the word. I distribute this. And I multiply out loud. -3 times 2x is, oh, oops. See, caught myself by saying it out loud. I'm so worried about doing the 9 here. -3 times 2 is -6x. -3 times -3, I'm verbalizing it so I don't make mistakes, is +9, and I copy the 8 down. Don't let them leave those things hanging. What are we doing? Good habits. I get my 6th graders, 7th graders, 8th graders to get those negative numbers and get some good habits. They're going to be in good shape for 8th grade, 9th grade, etc. Now I combine my like terms. Don't protect them from negative numbers. 5x and -6x is what? -x. Don't even say negative 1x plus 17. Okay? So, what are we doing in pre-algebra? We are laying a foundation in 6th grade, 7th grade, 8th grade, just for high school, just as much as 1st grade is laying the foundation for elementary.